This is a short course in astronomy. You'll be learning a few new facts and also some new terminology. This will set you above your friends when it comes to understanding the night sky. Maybe it will encourage you to learn more about astronomy. Hopefully, when you look up at the night sky after completing this course, you will have a better understanding of what you see. This is a study developed by a senior citizen. I'm not going to tell you how old I am, but here's a hint. I was born the year Clyde Tombaugh discovered Pluto. You'll have to take this course if you want to find out what year that was. Here we are looking up at the night sky. It looks like a giant bowl turned upside down. All the stars look alike, and they're at the same distance. Some are brighter than others, and believe it or not, there are stars we can't see. This course is dedicated to defining the night sky. After our short time together, hopefully you will never see the sky the same again. This is something you probably already know. These lines from the North to the South Pole and are called longitudes. You may remember that longitudes begin in Greenwich, England at 0, and they increase in number as they proceed both east and west. Latitudes are lines that proceed around the Earth, such as the equator, which is the beginning for longitude numbers at 0. As they proceed both north and south, they increase in size. Early mariners had trouble knowing where they were on the ocean. It wasn't until clocks became accurate enough for sailors to determine how far east or west they had gone. North and south was not a problem, as compasses had been around for a long time. This is a sextant, and using it to get the ship's longitude is called shooting the stars. I don't pretend to know how to operate a sextant. Basically, at a specific time of day, you point the sextant at an object in the sky. Then you measure the angle of that object from the horizon. This is converted into altitude. Converting to a chart shows you where you are on Earth. Binoculars may be the first instrument you select for your astronomical activity. Should you lose interest in astronomy, you will find that binoculars have much more usefulness than a telescope. The two figures that you see, 7 times 50, the 7 represents the magnifying power of your binocular, and the 50 defines your aperture or your light gathering ability. If you explore purchasing binoculars, you will find a large range of options, some so large that require a tripod to support its weight. The high-end binoculars can exceed the power of a small telescope. The number 7 by 50 is an ideal for astronomical activity. The two options available for your selection of telescopes are discussed. If you decide to take up astronomy seriously, it is recommended that you study the two types of telescopes that are available. Then make your decision based on your requirements. This is the other most common telescope, the reflector. Both the reflector and the refractor have some advantages and disadvantages. You may want to explore them before you make your decision on which one to buy. The refractor, a telescope that most of us are familiar with. Everyone knows that there are 360 degrees in a circle, and this is a no-brainer. There are 24 hours in a day. Now, to save you the time of dividing the number of hours into the number of degrees in a circle, you'll get the answer 15, which is the amount of distance that the Earth will travel in 1 hour. So we need to move our watches up by 1 hour for every 15 degrees that we travel. The answer is 30 degrees. Most everyone knows that it takes 365 1/4 days for the Earth to orbit the Sun, which makes us have a leap year every 4 years. The last leap year was in 2012. And here's a fact that few people know, so keep this in secret from everyone. It takes 365.25635 days. If it were 0.25 days even, then every 4 years would be a perfect leap year. Because it is larger than 0.25, we will have to compensate. So every 400 years, we will skip having a leap year. Probably most of you don't know the answers to these questions, so you'll have to turn to the next slide to find out what the answers are. I don't expect you to memorize these figures, but I think they're interesting. Notice that if the sun were to stop shining suddenly, it would take 8 minutes and 20 seconds for the Earthlings to find out. Think of it. Our nearest star is only 4.24 light years away. I guess we can't brag too much about the size of our sun compared to other stars, but a simple fact is the smaller the star, the more there are in the sky, and the larger the star, like Arcturus, the fewer there are. Here's a picture of the number of planets that are in our solar system. The first 4 planets are referred to as terrestrial, as they are land-based planets. The next 4 are referred to as gas planets, and they're much larger. You can tell that this is an old slide because Pluto is still included in the picture, but not anymore in our solar system. Notice that the first letters of all the planets begin with M, V, E, M, and so forth. That's kind of meaningful, so keep it in mind as we turn to the next slide. If you memorize this sentence, "My very earthy mother just sat upon 9 pins," it will help you recall the names and sequence of the planets in our solar system. Let's take the planets one at a time, and the first one nearest the Sun is Mercury. You might conclude that since it is the closest planet to our Sun, it is also the hottest planet, and that conclusion is incorrect. Later we will find out which planet is the hottest and why. Here are some interesting facts about Mercury. If you weighed 100 pounds on Earth, you would only weigh 37 pounds on Mercury. Mercury's year is only 88 Earth days. This is the time for it to orbit the Sun. Now, the side facing the Sun, the temperature rises to over 800 degrees Fahrenheit, while on the side opposite the Sun, the temperature plunges to a minus 300 degrees Fahrenheit. While it only takes 24 hours for the Earth to spin, it takes Mercury the equivalent of 59 Earth days for a Mercury day. Mercury has no atmosphere, and its surface is cratered, much like our moon. Cloud cover is the reason it is so difficult for us to see the planet Venus, the second planet from the Sun. Venus is also known as the Earth's twin sister, as it is about the size and close to the same distance from the Sun as Earth. Venus rotates so slowly that it takes 243 Earth days to equal one Venus day. But the year on Venus is shorter than its day, and it takes only 226 Earth days to complete its year. Venus is so hot, its surface can melt lead, and that is one reason why it is difficult to have a robotic exploration of the planet. It is believed that millions of years ago, Venus had water, much like Earth. But as the cloud cover was formed to prevent heat from escaping the planet, the phenomena is responsible for global warming, and it is feared that Earth may one day suffer global warming and become as uninhabitable as Venus. Earth is our next planet to discuss, and what can we say about Earth that you don't already know? Maybe you've seen this photograph pictured above. It is reported to be one of the most looked at photographs. The picture was taken from the moon, and it shows the Earth rising above the moon's horizon, much like the Sun rises above Earth. There are a couple of things in the sky not related to astronomy that you might find interesting. Someday you may be asked how many colors are in the rainbow and in what sequence. This slide will give you a clue, as if you can remember the spelling of this man's name, Roy G. Biv, it will describe the colors in their sequence. R for red, O for orange, Y for yellow, G for green, and so on. Astronomers probably don't care about our rainbow, but I thought you might be interested in it. This slide shows you the temperature range of stars and also the color associated with those temperatures. Remember that the hotter the temperature, the fewer number of stars there are in the sky. Our Sun has a G rating, and it is also assigned a 2, which further defines the temperature of our Sun, but we will not be concerned with that. Can you find stars of different colors in the sky? Notice that as the moon is increasing in size or waxing, the moon light is on the right. When the moon is waning or decreasing in size, the light side of the moon is on the left. Unfortunately for those living south of the equator, this rule is just the opposite. And when the moon is new, there is no moon. And that's the best time for us to see stars, as the moonlight sort of blinds us from the light of faint stars. We grew up puzzled by the old saw, the man in the moon, not knowing really what it was or who he was. On the moon, craters are found caused from two different sources. The first is meteorites that have impacted the surface of both the moon and Earth. Atmosphere on Earth has eroded much of the evidence of meteorite impact. However, the moon has no atmosphere, and the result is craters exist for millions of years. The second reason for craters are the caldera left behind by volcanoes. On the moon, volcanoes are now extinct, but no atmosphere leaves the volcano evidence for millions of years. There are mares, once thought to be seas, are actually solidified plains of lava left behind by the once active volcanoes. It has been almost 50 years since we landed men on the moon. No doubt in the future there will be more trips to the moon, but the next big adventure is to Mars, which will probably be much more difficult, much more complicated to perform. Voyager 1 was launched by NASA on September 5, 1977. It carried a gold-plated audio-visual disc in the event that the spacecraft is ever found by intelligent life. The disc is carrying photos of Earth and its life forms, a range of scientific information, spoken greetings from languages of all people, including the President of the United States, and a medley of sounds of Earth that include the sounds of whales, a baby crying, and waves crashing on the shore, and a collection of Earth music, including works by Mozart. Voyager 1 is now 124 astronomical units away from Earth. You may recall that one astronomical unit is approximately 193 million miles, as it represents the distance Earth to Sun. To find out how far Voyager 1 is from the Earth, you need to multiply 124 times 193 million miles. This slide shows that the Earth is tilted 23.5 degrees. This tilt is the reason that the Earth has seasons. If it were not for the tilt, the sun would always shine directly down on the equator. Notice also the plane of the ecliptic. That is the astronomer's name for the sun's passing through the sky. More about that later. This slide is of Mars, the fourth planet from the Sun. It's also known as the angry planet because of the color of the planet. Mars' temperature is very close to Antarctica's temperature, and from the standpoint it is habitable. However, there is no oxygen and no atmosphere to protect us from the sun's rays. There is much excitement about the possibility of Mars having water on its surface. NASA has sent several robotic probes to Mars. The latest one is named Curiosity. The next slide shows you a picture that Curiosity has taken of the Mars planet. It looks amazingly similar to our Arizona desert. As you can see, to avoid travel time, it is necessary to arrive on Mars when the Earth and Mars are the closest. We must consider the difference in orbits of Mars when we launch a Martian mission. A good mathematician is needed to figure this mission. Any volunteers? This is an artist's conception of the latest Martian probe named Curiosity. Curiosity has some intelligence on board due to the fact that transmission time from Earth to Mars and back again is so long that Curiosity could run into trouble before we could correct it. Another reason for onboard intelligence is the Sun comes between Earth and Mars for some 3 to 4 weeks. During that time, Curiosity is given some safe projects to pursue. Mars landing is quite an engineering feat, and NASA has some artist conceptions. It's worth your time to view it. Jupiter is by far the largest planet in our solar system. The Earth could fit inside Jupiter more than 1,000 times. If you traveled to Jupiter, you would weigh 70 pounds on Earth, and on Jupiter you could weigh 185 pounds, because Jupiter has more gravity. Jupiter's great red spot is where a giant storm has been raging for at least 300 years. Jupiter is considered a gas giant because it does not have a solid surface. Jupiter has officially 50 moons and 12 unofficial moons. The 4 largest were discovered by Galileo in the year 1610 with the aid of a telescope. Their names are Io, Europa, Ganymede, and Callisto. Ganymede is the largest moon in our solar system. It is the same size as Mercury, but a little bit larger. It rotates so quickly that only the days are 10 hours long. However, it takes 12 Earth years for Jupiter to complete the orbit around our Sun. Astronomers define Saturn as one of the most beautiful to observe. Saturn is the second largest planet in our solar system, and it has 7 flat rings that surround it. A couple of planets have rings, but their rings are so much fainter than Saturn's that it is difficult for us to see them. Saturn's diameter is equal to 74,600 miles, which is almost 10 times the size of Earth. The planet has been seen from Earth with the unaided eye, but its rings cannot. Saturn is the farthest planet from the Earth that ancient astronomers knew about. They named Saturn after the Roman god of agriculture. Some Saturn facts you may not know. 100 pounds of objects on Earth would weigh 116 pounds on Saturn. Saturn has the lowest density of all planets in the solar system. It is so light that it could actually float on water if there was an ocean big enough to hold it. It takes about 29.46 Earth years for Saturn to orbit our Sun. Saturn's rings are made up of billions of pieces of rocks and dust. This is Uranus, and it actually gives off less heat than it absorbs from the Sun. The other large planets have tremendously hot cores and radiate infrared radiation. But something made the core of Uranus cool down to the point that it doesn't radiate much heat. The axis of the Earth's rotation is tilted 23.5 degrees away from the Sun's plane, and Mars is similar, but the tilt on Uranus is 99 degrees. In other words, the planet is rotating on its side. All the planets look like a spinning top as they go around the Sun, but Uranus looks more like a ball rolling on its side. Summer on Uranus lasts 1 day long, 42 years. Uranus is 14.5 times as massive as Earth. Astronomers have been able to chart the wind speed on Uranus and have found that it can move at 250 miles a second. Make that 250 meters a second. Only one spacecraft in the history of spaceflight has ever made a close approach to Uranus. NASA's Voyager 2 zipped by Uranus in January 1986. Now the only planet left is Neptune. Neptune is a stormy planet. Winds here can blow up to 1,240 miles an hour. Neptune has 1/900th of the solar energy that reaches Earth. So far we've discovered 13 known moons. It takes 165 Earth years to orbit the Sun. Its diameter is 4 times the size of Earth, and Neptune lies on its side while it spins. But unlike Uranus, Neptune generates some heat. If you're interested, you can learn more about our solar system planets. I've just given you a bird's eye view of our neighbors. We all know that the Earth revolves around the Sun, and as it gets closer to the Sun, it becomes hotter on Earth. So this is a hint. Which one do you think is aphelion and which is perihelion? That last question was a trick question. Hopefully you'll remember how you got burnt, because the Earth is closest to the Sun in January and furthest from the Sun in July. Now we leave the solar system and begin to talk about the night sky from an astronomer's standpoint. Here are 2 terms that I'd like for you to become familiar with. Remember, a doctor has to learn new terms. He can no longer refer to your little finger as your pinky. He refers to it as your phalange. Now, the ecliptic is really a way that astronomers define the Earth's path reflected by the Sun. And the meridian is an artificial line drawn from the south to the North Pole that passes over your head regardless of where you are on Earth. Here's something you recognize every time you look at the night sky, the Big Dipper. But you may not know that the second star in the handle is really 2 stars. And if you can see the 2 stars, then you pass the Arabian eye test. If you can't see them, then you're probably going to need glasses. Now, the 2 stars at the end of the cup in the Big Dipper are known as pointers. as they point to Polaris, the star in the Little Dipper. Both the Big Dipper and the Little Dipper are useful to us as they point to other constellations in the night sky. We will make use of this later on in the course. But the Big Dipper and Little Dipper are not constellations. They're only part of the constellations. They're known as asterisms, which means they are recognizable patterns in our night sky. As you can see, Ursa Major has more than the 7 stars that are in the Big Dipper. Actually, the latest count is there are 86 visible stars in the Ursa Major constellation, as seen by the naked eye. Many of the bright stars in our night sky have a name. I'm not smart enough to remember the names of any of these stars. I'll leave that up to you if you want to memorize them. As you can see, the Big Dipper changes positions as it rotates around Polaris throughout the year. The cup only holds water in the Big Dipper in the fall. Something you should know, but you don't have to worry about, Polaris will not always be our North Star. Some 3,000 to 4,000 years from now, because stars move ever so slowly, Polaris will no longer be our North Star. You may recall that we use the pointers in the Big Dipper to point to the Little Dipper. Here's a sample of using the Polaris star that we located with the pointers combined with the middle star in the Big Dipper to locate Cassiopeia. This illustrates that we're using the Big Dipper again. Instead of pointing up to Polaris, we can point down to Leo. And using the curve in the handle, if we follow that, we can run into the constellation booties. So it's like a treasure hunt. You find one thing and it leads you to something else. I hope you enjoy it. Sirius is bright for 3 reasons, but as astronomers you can no longer use the term bright. You must refer to Sirius's magnitude. The magnitude of Sirius is due to 3 different reasons. The first is its size. If it were placed where our sun is, the size of Sirius would extend beyond Earth. The second reason is how close a star is. The closer a star, the brighter or higher its magnitude. And the third reason for magnitude increase is the temperature of a star. The hotter the temperature, the brighter the star. The artificial line that runs from the North to the South Pole and passes overhead is called the meridian. The point where it is directly over your head is called the zenith, and directly under your feet is called the nadir. And the meridian passes over your head no matter where you are on Earth. Astronomers locate stars by projecting the Earth's equator out into space, and the dotted line above represents the meridian, and it could be wherever you are on Earth. When the ecliptic crosses the Earth's equator going northward, it is known as the vernal equinox, and this is the date that astronomers stop all activity or motion of the sun, the earth, and the stars. When the ecliptic is moving downward and crosses the equator once again, it is known as the autumnal equinox, or the first day of fall. There are two kinds of magnitude. Apparent magnitude is what we actually see with our naked eye. The other magnitude is called absolute magnitude, and it's artificial. It assumes that all stars are placed at the same distance from Earth, so distance is not a factor in its magnitude. Notice that the visible magnitude with binoculars has increased to 9, while visible magnitude from Hubble has gone to 31.50. Notice as the brightness increases, the value of its magnitude decreases. And this is something that's confusing to me, because I would think it would be just the opposite. The value of a magnitude of 6 is the last value that we can see with the naked eye. Here's an overall view of some of the beautiful things that appear in our night sky. Comets can remain visible for weeks at a time. They are composed of rocks, ice, gas, and dust. The tail, if it's available, is lagging behind the bright part of the comet before it passes behind the sun. Once the comet emerges from behind the sun, the tail is in front. The tail can range in size from a few hundred feet to millions of miles. A bit of trivia. Samuel Clemens, or Mark Twain, was born when Halley's Comet appeared, and he died 75 years later when the comet reappeared, as he had predicted. Comets orbit the sun like Earth, but their orbital time may vary from a few years to thousands of years. This is a picture of a meteor that has entered the Earth's atmosphere. When it is floating out in space and not affected by our atmosphere, it is called a meteoroid. If the meteor survives the trip through our atmosphere and is not burned up and lands on Earth, it then becomes known as a meteorite. This is a view of a nebula as seen through a telescope. It may appear as a star when viewed with our eyes. A nebula could be the result of an exploding star. In billions of years, the gas and dust in the nebula, as a result of gravitational pull, may form a new star. A meteor shower begins when the debris from a comet's tail enters the Earth's atmosphere. The Perseus meteor shower occurs annually in July and August. During its peak, as many as 60 or more per hour can be seen. This particular meteor shower has been known for over 2,000 years. We'll be handing out some hard copies of slides like this and others that you will find useful in your further studies of astronomy. Here are some astronomical terms that were introduced to you in this course. If you have any questions about them, now is the time to ask. This is one of the most complicated instruments that you've probably ever used to date. So let's take the complexity apart a little bit at a time. The first thing you notice that the night sky is no longer blue, it's white. And the second thing you'll notice is that the stars are not white, but they're black. And the star's magnitude is represented by a larger dot. The larger the dot, the brighter the star. You can see stars for every day of the year and their location for the time from 6 p.m. to 6 a.m., the normal time for stars' visibility. Select the night sky side to see the northern hemisphere, and to see the southern hemisphere night sky, turn the planisphere over. At the top of the planisphere is 30 to 40 degrees latitude. Your view of the night sky changes with the latitude. For example, if you were at the North Pole or 90 degrees north latitude, Polaris would always be directly overhead. On the other hand, if you were on the equator at latitude 0, Polaris would be on your horizon. Each degree of latitude is about 70 miles. The latitude of 30 to 40 degrees give you about 700 miles of viewing. The hole in the center of your planisphere represents the North Pole, while the hole at the top of your planisphere represents the South Pole. The imaginary line drawn between the two could be your horizon. The gray smudges that appear across the sky represents the Milky Way, and you will notice that constellations are outlined on your planisphere. The dark part of the bottom of your planisphere is actually daylight, and the stars disappear once they fall behind the dark daylight hours. The right side of the planisphere is the eastern horizon, and the left side of the planisphere is the western horizon. Remember this slide, it shows you the position of the Big Dipper for the 4 seasons. But you have with your planisphere to figure out the position of the Big Dipper for every day of the year. Let's see if we can follow the path of the Big Dipper as you rotate your planisphere. Now let's put the planisphere in action. Normally the stars will move counterclockwise. Let's rotate the planisphere to April 20th at 9 p.m. Notice that March 20th at midnight the stars look the same as they did on April 20th, and December 18th at 5 a.m. Locate the star Vega rising at 9 p.m. on April 20th. It also rises at midnight on March 5th. Do you see the constellation Orion on the far left of your planisphere? The star Rigel is setting in the night of April 20th at 9 p.m. and it's also setting at midnight on March 5th. Remember the imaginary line between the two holes, the North and South Pole, is called our meridian. The constellation Leo is under our meridian. The stars in Regulus is crossed under the meridian. Does everyone see that? As an object crosses under our meridian, it is said to transit our meridian. Don't forget the ecliptic. It is marked with dotted lines on your planisphere. The equator is the solid line. Remember what we call the time when the ecliptic crosses the equator heading north, and when it's heading south, the ecliptic crosses the equator is called the first day of fall. Let me mention something you can explore on your own. Right ascension, for astronomers, is the equivalent of Earth's longitude. Right ascension values are marked by tick marks for every hour on the planisphere's celestial equator. Although the values of right ascension are not labeled, the line corresponding to 0 hours, right ascension, can be located identifying the vernal equinox. Declination is the equivalent of Earth's latitude. Declination on your planisphere is at the North Pole, or 90 degrees north. It is reduced by 10 degrees as it proceeds south to the equator with 0 degrees latitude. Unfortunately for the small planispheres, right ascension and declination numbers are not shown. But for a challenge, see if you can locate Arcturus in the constellation Bootes, which has a right ascension of 14 hours, 0.20 minutes, and a declination of 20 degrees. That's a challenge. See if you can find out. Again, on April the 20th, notice that the constellation Leo is going under your meridian. And that meridian runs from the North to South Pole. Another challenge. We're going to check out our planisphere to see if it actually shows us the location of stars.